So this is a video of me going over the Unit 7 test review on right triangles. The first thing obviously is the formulas. Pythagorean's theorem here is on the upper right hand corner of your formula sheet, and the trig ratios are in the upper right hand corner of your formula sheet. However, these three formulas here, the one for the 45, 45, 90 and the two for the 30, 60, 90 are not on the formula sheet. So you need to make sure that you have these memorized for the test. So 45, 45, 90 is the hypotenuse is equal to the leg times the square root of 2. And remember that we know that it's a 45, 45, 90 because two legs are congruent, thus two angles are congruent, or two angles are congruent, thus two legs are congruent. With this one, the 30, 60, 90, we have two formulas. The hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. Now, I told you guys that if you can keep the square root of 3 straight with the 30, 60, 90, because it has three separate angles measures, then you should be able to keep the square root of 2 straight for the 45, 45, 90. So for the next set of problems, 7, 8, and 9, the very first thing we want to do is we want to compare two sides to the third and do this 3 times. We're going to add two sides together and compare it with a third. So 7 plus 12 equals 19. 19 is greater than 16. 7 plus 16 is 23. That's greater than 12. 12 plus 16, that's greater than 28 is greater than 7. So we can make a triangle with those three sides. We could do that for all three of these, and that's the way we do it. So for all three of these, it is true that we can make a triangle on it. Then what we want to do is compare a squared plus b squared to c squared. Recalling that if c squared is bigger than a squared plus b squared, then it's an obtuse triangle. If c squared is equal to a squared plus b squared, then it's a right triangle. And if c squared is smaller, then it's an acute triangle. So that's what I did here again. I squared the 16 because that was our longest side. This 16 up here was our longest side, so we know that that's going to be our c every time. Over here, we would have done the 12 squared and compared it to the 7 squared plus the 10 squared. Here we would have squared the 41, and we would have compared it to 9 squared plus 40 squared. So in the first case with number 7, we got that 256, which is our c squared, is bigger than the 193, which is equal to the 49 plus 144. So because c squared is bigger than a squared plus b squared, it's an obtuse triangle. Over here, we had 144 was less than 149. So again, this is our c squared, because that was our 12, our longest side. If c squared is smaller than a squared plus b squared, then it's an acute triangle. And here we had an equal sign. So when we added these together, the 9 plus the 40, we got the same number on either side of the equal sign, that meaning that they were equal. So these two triangles are right triangles. The next set of problems says find the missing side lengths, also tell if it forms a Pythagorean triple. So on this one, we're just basically finding what is C. Our C is always the angle that's opposite the right, always the side that's opposite the right angle. So that means 6 and 5 would be A and B. So we square those two, and then we set them equal to x squared. 36 plus 25 is 61. 61 is a prime number, and so when we take the square root of 61 and the square root of x squared, we get that x is equal to the square root of 61, which is not a Pythagorean triple because it's not a whole number. Number 11 here, again, first thing we got to do is figure out what is the hypotenuse, and 13 is our hypotenuse here. So we're going to do 12 squared plus x squared, set that equal to our 13 squared. Work through this problem. We get 144 here for 12 squared. We're just going to subtract that from 169. That gets us 25, and the square root of 25 is 5. This one is a Pythagorean triple, again, because we have 12, 13, and 5 as our sides, and those are all three whole numbers. So for the next set of problems, 12, 13, and 14, it says find the value of each variable, write your answers in the simplest radical form. So the first thing we need to do is look at these drawings and see if there's any way that we can tell what kind of triangles these are. And I happen to notice with number 12 that the sides are congruent. And if the sides are congruent, then I know that this is a 45, 45, 90 triangle. So if it's a 45, 45, 90 triangle, then I have one formula for that, and that is H equals L square root of 2. So then I have to look at what do I have, and I have the hypotenuse, the side that's opposite the right angle. So I'm going to put 10 here, and I know that x and y are going to be the same, so I'm just going to put x in here, square root of 2. Now, I got to get rid of that square root of 2 because I'm solving for x. So I'm going to divide both sides by the square root of 2. So now that is gone from there, and that gives me that x is equal to 10 over the square root of 2. Now, I can't leave a square root of 2 or a radical in the denominator, so I have to multiply that by the square root of 2 over the square root of 2. Now, when I do that, I'm going to get 10 square root of 2 over the square root of 4. And that's going to be 10 square root of 2 over 2. And then I notice here that I can divide the 2 into the 10. So our answer is going to be 5 square root of 2. That is the value of x. And what I recall up here is that x and y are equal, so that is also the value of y. Now we're going to go on to the next problem. So I'm going to erase this so I have more room to work. You can go back and watch that part of the video if you need to see it again. Okay, so now here again, I notice that I have two sides that are congruent. If two sides are congruent, we know it's a 45, 45, 90 triangle. So we have that this is a leg, so that means this is also a leg over here. So if one of our legs is 13, then the other leg is going to be 13. So that means x is going to be equal to 13. And then we're just going to use our formula because we know that this is h, our hypotenuse. So h is equal to L square root of 2. And our L was 13, so y is equal to 13 square root of 2. So there's our two answers for a 45, 45, 90 triangle again. 14, same thing. We have two sides that are congruent, so that tells us again this is a 45, 45, 90 triangle. And again, this time we have the hypotenuse and we have a leg and a leg. So we need our formula for the hypotenuse. So h equals L square root of 2. So again, we're going to substitute in 18 equals, and we'll go ahead and say x square root of 2. Again, we have to divide both sides by the square root of 2. So now we have the square root of 2 gone from there. So x is equal to 18 over the square root of 2. If you recall, once again, we cannot leave a radical in the denominator. So we have to multiply both the top and the bottom by the square root of 2. That's going to get us 18 square root of 2 over the square root of 4. And we can take the square root of 4, so that's going to be 18 square root of 2 over 2. And again, these two can be reduced. So that's going to give us 9 radical 2. So here, x is equal to 9 square root of 2, and so is y, because again, those legs are congruent. So now we're going to do the next set of 15, 16, and 17. So 15, I see that I have a 60-degree angle here. So that means this one has to be 30. So we know this is a 30, 60, 90. This has two formulas. The hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. So let's go ahead and figure out what these sides are first. So I know that across from the 30-degree angle is the short side, so S is equal to 20. We also know that across from the right angle is the hypotenuse, so that's our hypotenuse. And this is going to be our long leg. So now we can go ahead and work the problem. So we have the short leg, so we could say the hypotenuse, actually let's go ahead and just put y in here. So y is the hypotenuse, and that's equal to 2 times 20, which is the short leg, so y is equal to 40. Then we have the long leg. The long leg is equal to the short leg times the square root of 3. So again, we're going to look at the long leg. It's x. Our short leg was 20, so that's just 20 times the square root of 3. So there's our x and our y. So over here again with number 16, we have another 30, 60, 90 triangle because we have a 60-degree angle, and that means that one's 30. So opposite the 30-degree angle, again, is the short side. Opposite the 60-degree angle is the long side, and opposite the right angle is the hypotenuse. So here again, we can say that h is equal to 2 times the short leg, so y is equal to 2 times 8, which means y is equal to 16. Then we can say that the long leg, which is x, is equal to the short leg, which is 8 times the square root of 3. That was our formula for the long leg. And number 17, again, another 30, 60, 90, because this would have been 60 out here. And these both are x because it shows us that x is down there is congruent with that part up there. So this and this mean those are congruent. So now, again, we look at across from the 30 degree. So this is our short leg. Across from the 60 degree, this will be our long leg, and this will be our hypotenuse. So this time we have the long leg, so we're going to use a long leg formula. So the long leg formula is equal to the short leg times the square root of 3. So we're going to put 15 in here, and our short leg was x, square root of 3. So we're going to work this like we did the 45, 45, 90s, and we're going to divide both sides by the square root of 3. That gets it gone from there, so x is equal to 15 over the square root of 3. And again, we can't have that radical in the denominator, so we need to multiply top and bottom by the square root of 3 over the square root of 3. That's going to be 15 square root of 3 over the square root of 9. We know that the square root of 9 is 3, so 15 square root of 3 over 3. Again, those can be reduced. So our answer here for x is going to be 5 square root of 3. Now x was our short side. So now we're going to solve for our hypotenuse, which was our formula h equals 2s. Now our short side is that 5 radical 3. So we got y for our hypotenuse, 2 times 5 square root of 3. If you recall, we only multiply the 2 and the 5. So this is going to be 10 times the square root of 3 for our answer for y. The next set of problems says find the value of each variable and round decimals to the nearest tenth. So on this one, I notice that I have a 72 degree angle and I have a side of 3. So we're going to use our trigonometric ratios to solve for the sides x and y here. And we're going to use our angle and how these sides relate to that angle. So first of all, if we look at this side 3 down here, this is adjacent to our angle. If we look at our y, that's our hypotenuse. And if we look across, this is going to be our opposite. So I say let's go ahead and solve for x first. So we're going to look at the ratio of A and O, which is adjacent over hypotenuse, and that's our tangent ratio. So when we say the tan of 72 is equal to the opposite, which was our x, over our 3. And remember, if we have a 3 in the denominator, we're going to multiply 3 times both sides. So that's going to be 3 tan 72, and that equals x. We can put this in the calculator exactly like this, 3 tan 72, and it's going to give us our answer for x. So x is equal to 9.2. Now at this point, we really have two choices about how to solve for our hypotenuse. We could use Pythagorean's theorem and do 3 squared plus 9.2 squared equals y squared, or we can use another trig ratio, and I'm going to go ahead and use another trig ratio. So this time I'm going to solve for y. So we have our adjacent side here, we have our hypotenuse, and adjacent and hypotenuse use the cosine. So cosine again of 72 is equal to our adjacent, which is 3, over our hypotenuse. Now this one's a little different because our variable's in the denominator. So what we're going to do is we're going to swap the cosine of 72 with the x. So x is going to be equal to 3 over the cosine of 72. When we do that, we get that, sorry, this should be y, my bad. That should have been y, y'all. I don't know why I put x up there. Should have been y. Let's go ahead and fix this, because that was our hypotenuse, y and y. So then we can do this on our calculator again, y divided by the cosine of 72. So y is equal to 9.7. All right, now let's look at number 19. Again, let's see what kind of ratios we have here. So we're looking at the hypotenuse here, that's our hypotenuse. The y is our opposite, and the x is our adjacent. So if we want to go ahead and solve for our x first, then we're looking at, we have our hypotenuse and we have our adjacent. Adjacent and hypotenuse, the ratio we use for that is cosine. So we're going to say the cosine of 63 equals adjacent over hypotenuse. sorry, which that would have been x over 12. So again, we multiply both sides by 12, so that would be 12 cosine of 63 equals x. So our x is going to be 5.4. Then we can use another ratio to solve for y. Now our y is our opposite and we had our hypotenuse, and when we have opposite and hypotenuse, that's our sine ratio. So sine of 63 is equal to y over 12. Here again, we're going to do 12 times the sine of 63, and that's going to be our y. We can put that directly into our calculator, and it tells us y is equal to 10.7. Now, as I said before, when we got that 5.4, we could have done a squared plus b squared equals c squared to solve for y as well. So number 20. Again, let's look at what ratios we have here. So this is our hypotenuse, the 25 and the x, that's our opposite, and this would be our adjacent. So when we look at this problem, if we solve for x, we have our opposite and our adjacent, and that is our tan ratio. So tan of 25 equals opposite over adjacent. So that would be x over 10. Again, we're going to multiply both sides. So 10 times the tan of 25 equals x. So x here is equal to 4.7. Then, when we're trying to find y, we could use adjacent and hypotenuse, and that's our cosine. So that's going to be the cosine of 25 is, again, equal to the adjacent, which is 10, over the y. And this is where we swap things again. So when we swap here, we're going to say that y is equal to 10 divided by the cosine of 25. And when we do that, we get that y is equal to 11. Okay, we're on number 21. Tom built a ramp that is 5 feet long from the ground to the porch that is 2 feet high. Find the angle the ramp makes with the ground to the nearest degree. So when we do this, we have to figure out where the angle is we're looking for. And the angle we're looking for is this angle down here. So if we're looking for that angle, then we got to figure out how do those two sides relate to that angle. This is opposite and this is adjacent. Again, so we're thinking, what ratio is that? Opposite and adjacent, that's tangent. So we're going to say the tan, now remember, we're doing the inverse here because we're trying to find an angle, and we use inverses when we're trying to find angles. So we're going to do inverse tan of 2 over 5 because that's opposite over adjacent. And when we do that, it tells us that this angle is 22 degrees because this tells us, again, to round it to the nearest degree. So when you guys are doing this inverse tan on your calculator, you're going to push second in the tan button, and that's how you get inverse tan. Okay, for this next set of problems, it says use the given trigonometric ratio to determine whether angle 1 or 2 is A in each problem below. Okay, so what I'm going to do first is I'm going to go ahead and work the sine of angle 1 and the cosine of angle 1 and the tan and the sine and all that stuff. So I'm going to do all of these for angle 1 first. So I'm going to do the sine of angle 1 is equal to, sine means opposite over hypotenuse, so that would be 6 over 10, which reduces to be 3/5. Then I'm going to do the cosine of angle 1. That equals adjacent over hypotenuse, so that's 8 over 10, and that equals 4/5. Then I'm going to do the tangent of angle 1. That equals opposite over adjacent, so that's going to be 6 over 8, and that means that's going to be 3/4. Then I'm going to do angle 2. So I'm going to do the sine of angle 2, and again, this is going to be opposite over hypotenuse, so that's 8 over 10. That equals 4/5. Then I'm going to do the cosine of angle 2. Cosine is adjacent over hypotenuse, so that's going to be 6 over 10. So that's going to be 3/5. And then I'm going to do the tangent of angle 2. And again, tangent means opposite over adjacent, so this is going to be 8 over 6. So that's going to be 4 over 3. Now we can figure out what this question is asking us. We're trying to figure out which of these is angle A. So is it 1 or 2? So the sine of A, so we're looking for the sine of A equals 3/5. So the sine of angle 1 equals 3/5. So that's this one right here. So that would be angle 1. Then we're looking at the cosine of A is 4/5. So cosine of A is 4/5. So again, that would be this one right here, cosine of 1, so that's angle 1, was 4/5. Then it says the tangent is equal to 4/3. So we got tangent up here is 3/4, and then tangent is equal to, for angle 2 is equal to 4/3. So this is the one we're looking for here. So this would be angle 2. That's how you're going to solve for this problem. So 25 says when the angle of elevation to the sun is 37 degrees, a flagpole casts a shadow of 24.2 feet long. What's the height of the flagpole to the nearest foot? So this is what we're actually looking for right here. We're looking for the height. So we want to see how these two sides of this triangle relate to that 37-degree angle. Now our height was our opposite and the 24.2 is our adjacent. So that means if we have opposite and adjacent, if we look on our formula sheet, we're going to see that that's tangent. So we're going to say the tangent of 37 degrees is equal to opposite over adjacent, so h over 24.2. Again, we're going to bring that 24.2, we're going to multiply both sides by it. So 24.2 times the tan of 37 is equal to h. So our answer here for h is equal to 18 feet. Because again, this tells us to round it to the nearest foot. So now we're on 26. It says a surveyor finds the angle of elevation to the top of a 100-foot tower is 67 feet. To the nearest foot, how far is the surveyor from the base of the tower? So what we need to do first is we need to figure out, we need to draw a drawing for this. So let's draw a drawing like this. We have a right angle here. It says that we got 1,000 feet here. And then we've got that the elevation to the top of the tower is 67 degrees. So it's asking us how far away is the person. So what we're looking for is this right here. So again, we got to figure out what ratio we're going to use. So we look at this 67 degrees. We've got opposite here and we've got adjacent here. That's our tangent ratio. So we're going to say the tan of 67 equals 1,000 over d. Here again, when we have the variable in the denominator, we're going to swap places here. So this is going to be d is equal to 1,000 divided by the tan of 67. So our answer is going to be for d, when we divide 1,000 by tan 67, it's going to be 425 feet. Now, the next part of this problem, so how far back would the surveyor have to move so the angle of elevation to the top of the tower was 55 feet, or 55 degrees, sorry. So now we want this to be 55 degrees, and this is still 1,000 feet. So when we work this problem now, we're still looking for our d down here. This is going to be our opposite, and this is going to be our adjacent. So we're still going to use our tangent ratio here. So we're going to say the tan of 55 this time is equal to 1,000 divided by d. Swap places again with our variable in our tan 55. So d is equal to 1,000 divided by tan 55. That answer was 700 feet. Then it's asking us how much further did we have to move back. So we're going to do 700 minus 425, and that equals 275. So the amount we had to move back was 275 feet. So number 27 says, May is flying a plane at an altitude of 1,600 feet. She sights a stadium at an angle of depression of 35 degrees. What is May's approximate horizontal distance from the stadium? So this is what we're trying to find, the horizontal distance down here. And if you notice up here, we have a 35-degree angle here. And these two lines are parallel. So if they're parallel, then we know that this angle is congruent with this angle. because of alternate interior angles. So this is also 35 degrees. So then we're talking about what are these two sides here. Actually, let's make this D down here so we don't confuse it with the hypotenuse. So when we're looking at these two sides now, we can talk about, we have the side that's opposite. This would be opposite right here because it's opposite the 35-degree angle. And then we have the D down here, which is going to be adjacent. So if you look at your formula sheet, it in what ratio uses opposite and adjacent, it's tangent. So we're going to say the tangent of 35 degrees is equal to opposite, which is 1600, over adjacent, which is our D. If you recall, when we do this type of problem, we're going to swap the tangent 35 and the D. So the tangent 35 and the variable. So D equals 1600 divided by the tan of 35. Put this in your calculator just like this, and you get 2,285 feet. That's what the distance is from May's approximate horizontal distance from the stadium, basically. So the last set of problems on this review says solve for the missing pieces of the triangle. So in this first triangle for number 28, we have two sides, but no angles besides the right angle. So we're going to go ahead and solve for one of these angles first, and then we'll solve for the other one. So if we're looking at this question mark here, and we look at how these two sides relate to it, we've got the hypotenuse here, and we've got the adjacent here. We know that that's the cosine ratio. Now, when we're looking for angles, we use inverses of ratios. So we're going to say the inverse cosine of opposite over adjacent, adjacent over hypotenuse, which is 28 over 57. And we put this in our calculator. It tells us that this angle that we're looking for, this question mark angle, is equal to 60.6 degrees. Now we could find our other angle in here, this angle down here, by just subtracting the 60.6 from 90. So 90 minus 60.6 is equal to 29.4 degrees. Now it says that we're supposed to solve for all the missing parts. We have two sides of this triangle and we need a third side. So we have the hypotenuse and we have one of the sides. So we're going to go ahead and solve this by saying a squared plus b squared, which we don't know, and we'll call this down here b, is equal to 57 squared. When we do that, we square the 28, we square the 57, we subtract the 28 squared from the 57 squared, we get that b squared is equal to 2465. Then we're going to take the square root of 2465, and that's going to give us 49.6. So these are our three parts that we were missing: one angle, two angles, and the third side. So with number 29, same process. So this time again, we're going to find this angle up here. So we're going to use what we have. Again, we have the hypotenuse. This time we have the opposite. If you look on your formula sheet, you'll see the opposite and hypotenuse is the sine ratio. So we're going to do the inverse sine of opposite over hypotenuse. When we do that, it tells us that this angle is, this question mark angle is 34.5 degrees. Okay, then we're going to subtract that from 90 to find the other angle. And that equals 55.5. And then we need to find our third side. So again, we have our hypotenuse, we have one of our sides. So this time I'm just going to use the variable x for this side right here. So I'm going to do 34 squared plus x squared equals 60 squared. That's going to give me 1156 plus x squared equals 3600. Going to subtract 1156 from 3600. That gets me x squared equals 2444. Then I'm going to take the square root of both sides of that, so x is going to be 49.4. So again, we've solved for three missing parts: angle 1, angle 2, side 3. So our last problem over here, again we have this angle here, and then we have our hypotenuse and adjacent side. So again, we're going to talk about the cosine ratio. So we're going to say the inverse cosine of 18 over 27, because that's adjacent over hypotenuse, that was equal to 48.2 degrees. Going to subtract that angle from 90 to get our third angle. That gets us 41.8 degrees. And then we are going to solve for our third side. Again, we have our hypotenuse and we have one of our sides. I'm going to call this one x again. So we're going to say 18 squared plus x squared equals 27 squared. So that's going to be 324 plus x squared equals 729. Subtract the 324 from the 729. We get that x squared is equal to 405. And then we take the square root of both sides, so x is equal to 20.1. So once again, we have angle, angle, third side.